guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the coefficient of mean deviation, and this is going to be part of the different types of measures of dispersion which I've mentioned in some of our videos. Now, in this case, we're going to look at some of the ways in which we can evaluate the concept of coefficients of mean deviation, and this is going to be a derivation of different types of averages which we have done, of course, in trying to find the mean deviations about the mean, median, and mode, which are given in terms of an illustration. So we're going to consider this specific set of data which I've given on the right side of the board. But of course, I'm going to request our members as well to check our description box, where I'm going to put a video whereby we are done on an evaluation of various aspects of different averages for the mean, mode, and median. And of course, that's going to assist us in trying to comprehend this aspect of the coefficient of mean deviation. Now, in this case, we have done an average for this specific set of data and given it in terms of relative representation. And of course, we have said that for us to find the average, we are going to find the summation of this one divided by the number of observations, which gave us a value of 6. Of course, that was from our previous discussion, as I said. And of course, we had found our median, which was given in terms of this notation, which we said was 5.5. And then we had found our mode, which was the most frequently appearing distribution, in this case, which was a value of 5. In this case, we proceeded to find the various measures or rather median deviations or mean deviations about these different averages, whereby I mentioned that for us to find the mean deviation about the mean, we were finding the summation of values between the first one and the nth distribution, or the nth value, which we had said, of course, was 10 in particular. So therefore, this was giving us the definition of the individual values of this one from the mean as an absolute value divided by the value of 10. And this gave us, of course, a value of 1.4 given as such. So this one constituted the mean deviation about the mean. And then secondly, we had evaluated the mean deviation about this specific median. And then we said that this is basically the summation of I from 1 to 10 of the difference between this median and 5.5, which was a value that we had obtained from this specific evaluation, divided by 10. So this also gave us 1.4. And then lastly, we had found the mean deviation about the mode given as such, which was the summation from the first one to 10 of the difference between this specific. So basically, this is going to be the value of xi and not x mean given as such. So the difference between the values of xi, which is representing individual values, and of course the mode, which was 5, and this is going to be divided by 10, and this one as well gave us the value of 1.4. So this particular, of course, result was consistent for the mean, median, and mode for various mean deviations about the various averages which have listed in terms of that specific distribution. Now, in our case for today, we're going to look at the coefficient of mean deviation, and we're going to see that the coefficient of mean deviation basically is the average between the mean deviation and average about which the deviations are taken, and therefore we can give this one in terms of a representation of the coefficient. I'm going to divide my table in this. So we're going to have this one given as a coefficient of mean deviation is given as the mean deviation all over the specific average that we're going to consider. In this case, if we are going to find the coefficient of mean deviation about the mean, this is going to be given as the ratio between the mean deviation divided by the mean given as such. And then we're going to find the coefficient of the mean deviation, of course, about the mode given as the mean deviation divided by the mode given as such. And lastly, we can find the coefficient of the mean deviation about the median given as the mean deviation divided by the median given as such. So that's going to give us an evaluation of various coefficients of mean deviation. And of course, we can do that one using our various example. Now, in this case, if we are going to find, let's call this one our first one, second, and third. So the coefficient of the mean deviation about the mean is given as CMD is equivalent to the mean deviation. Now, in our calculation, we had found the mean deviation about the mean as 1.4 divided by the mean. So our mean was a value of 6, and therefore that's going to give us 0.233 as our coefficient of the mean deviation given as such. And then coefficient of the mean deviation about so this is going to be the mode, is 1.4 divided by the mode. The mode was 5, and therefore that's going to give us the value of 0.28. And then lastly, we're going to find the coefficient of the mean deviation about the median, which was giving us a value of 5.5. And this is going to give us, of course, the value of, so I'm going to do an evaluation of that one. So this is going to be 0.255. So kindly do an evaluation to confirm this, especially the last figure. So in case we find a difference, kindly give us a notification in the comment section so that we can do a rectification. Now in this case, this is how we are going to evaluate various aspects of the coefficients of means of deviations of different averages for the mean, mode, and median given as such. So I'd like to encourage our members to kindly subscribe, engage us in the comment section, and also subscribe to our, or rather, of course, check our description boxes for various links of other similar videos which I'm going to put there. So that is it for now, guys. Bye. God bless you. Catch us in our next video.